Okay, for chapter 5, what we're going to do is we're going to have a look on graph of trigonometric functions. So that is going to be for chapter 5. And we're going to start with 5.1, so which is going to be trigonometric functions. So we're going to discuss about periods. Okay, so first of all, before we start with our discussion on trigonometric function, I would like to explain to you what is a periodic function. So periodic function, according to the definition, is a function that repeats itself on a regular interval, and this regular interval has a specific name, so it is called as being the period. Okay, an example of periodic function, so all trigonometric functions, sine, cosine, tangent, and all, so they are all periodic function. So we can actually see periodic function clearly, we can identify them easily from the graph itself. If it has the same shape being repeated over and over again, so that is a characteristic of a periodic function, and that is shown by these two graphs over here. So we basically have two graphs that have the same shape being repeated over and over again. So here, so how does one cycle actually look like? So this is called as being one cycle, and the idea is you're going to copy and paste. So if I were to copy the shape, so this is how it's going to look like, and copying it for another time, so this is how it looks like. So each of this, so one of the shape, so that is known as being one cycle. So this is going to be one cycle, so this is going to be one cycle, so this is going to be another cycle. And basically, what is going to be the period? So period, let me put over here. So period is actually distance of one complete cycle. Okay, for this particular graph, how many cycles do I have? I have 4 of them. This is the first one, second, third, and fourth. So what is the distance for one complete cycle? So distance from here to here, so let me have a look. So this is going to be from 0 to 1. So this is going to be 1 unit. So therefore, for this case, what is going to be the period value? So the period value is going to be 1 unit for each of the cycle. Right, if you have a look from here to here, that is 1 unit. From 1 until 2, that's 1 unit. From 2 until 3, that is 1 unit. So every cycle is going to have the same distance, and that is called as the period. And for this case, the period value is going to equal 1. So let me show you another example. So it's going to be this function over here. So if you notice, how does one cycle looks like? So we can assume that one cycle actually looks like this. So it's an inverted triangle. Okay, it's an upside down triangle. So that is going to be one cycle. And how many cycles do I have over here? So this is going to be one cycle. This is second cycle. This is 3 cycle. So I probably have like 3.5 cycle over here. And what is going to be the period value? So the period value is going to be the distance of one cycle. For example, I can take it from here to here. So that is a distance from 3 to 9. So therefore, what happened is that the period value, so that is going to be 9 minus 3, so which is going to be 6 units. So the period value is going to equal 6. So if you notice, so that is why we have a function written over here. So this is how periodic functions are written. And this value over here, so it's actually telling you about the period value. So ft is equal f of t plus 6, telling us this is a periodic function for which the period is going to be a value of 6. The same goes for the previous function, which I'm referring to this one. So what is our period value? The period value is going to equal 1. From here, we can tell right away. So this is going to be the period value, and it is consistent from what we have seen from the graph. So that is going to be the same idea for the case of trigonometric function as well. So for the case of sine, cosine, and tangent, so what happens is that they have the same shape that is being repeated over and over again. For example, if I were to sketch a sine function for you, oh, that's an ugly circle. Okay, so this is a sine function. So that's going to be 1 cycle, 2 cycle, 3 cycles. So basically, it's the same shape that is being repeated over and over again. And it happens for all trigonometric function. So that is why all trigonometric function are called as being periodic function. And of course, there will be a period value. Okay, the period value for sine and cosine is going to be the same. So what happened is that this is going to be from 0 to 2 pi. So this, for sine function, this is considered as being 1 cycle. And of course, this is going to be second cycle, and this is going to be the third cycle, and so on. Okay, so every 2 pi value, so the shape is going to repeat. And the same goes for cosine. We're going to have a look at that later. So the period for cosine is also going to equal 2 pi, but for tangent, so it's going to be slightly different. So tangent, the period value is going to equal pi. So which actually refers to this equation over here. So this is called as being the periodicity of sine and cosine. So because we have the same shape being repeated over and over again, for example, what happened is that, so if I were to pick any value that is on the top over here, so after 2 pi value, so I'm going to come across the same shape again. And after 2 pi value, so it's going to be the same shape over and over again. So that is why, so we have this property which is called as the periodicity of sine and cosine. So the value of sine of t plus 2 pi k is going to equal sine of t. And the same goes for cos. Cos of t plus 2 pi k is going to equal cos of t. And this 2 pi over here, so what is this 2 pi value? So this is actually the period value. And k is actually an integer. So what is an integer? Integer is a whole number, counting numbers, but it could be in terms of positive and also negative. It could be 0 as well. So it could be negative numbers. For example, I could put over here -3, -2, -1, 0, 1, 2, 3, and so on until infinity. So this is what is called as being an integer. So this k value could be positive, it could also be negative, but it's going to be counting numbers 1, 2, 3, 4, 5, 6, 7, and so on. It cannot be fraction, it cannot be in terms of decimal places. It is called as being integer. Okay, so this is the example. So we are going to evaluate each of the expression over here. So by using the periodicity property. Okay, first for A, so we are going to evaluate what is going to be the value of cos pi plus 2 pi. So you can actually use simply use your calculator over this. Cos of pi, 3 pi, what is going to be the value of that? But usually for this kind of calculation, we would actually specify. So without using your calculator, so you have to use the periodicity of sine and cosine and find the value of each of this expression. Okay, if I were to compare, so with what I have over here, so basically what is going to be the k value for this case? So for this case, my k value is going to equal 1. And according to the formula, so what is going to be my t value? So this is my t value. So my t value is going to equal pi. So therefore, if I were to compare, so it says that cos of t plus 2 pi, so that is going to equal cos of t. So this is the periodicity formula that I have on top. So I identify that my t value is going to equal pi. So that is why for this case, so cos of pi plus 2 pi, so that is going to equal cos of pi. And we know what is going to be the value of cos of pi. So remember, if you use your calculator to find trigonometric function that is in terms of radian, so we don't have degree over here, so we have cos of pi, we know that it's going to be radian unit. Please make sure that you change the mode of your calculator, made it in terms of radian, then only start using your calculator, or else it's going to give you a different value because the calculator doesn't know whether it's going to be degree or radian. You have to set that in your calculator. And what is going to be the value of cos of pi? Let me imagine the graph first. So cos of pi, so the value is going to equal -1. So I think so. Let me check that. So cos of pi. So where's my pi value? Yep, so that is going to equal the value of -1. Okay, so that is going to be the first example. So the second example. So now it's going to be sine. So I have sine of pi over 2 minus 6 pi. So let me put the theorem at the top. So I'm going to have sine t plus 2 pi k. So that is going to equal sine of t. And let me put the expression underneath. And for our case, we have sine of pi over 2 minus 6 pi. So we are going to evaluate this. Okay, first of all, so whatever that comes with the pi, so that might be this part over here, so which is going to be the part where you have 2 pi k, and this one is going to be very obvious. And what happened is that here we can identify right away what is going to be our k value. So our k value is going to equal -3 because 2 pi k is going to equal -6 pi. So I can cancel this and this. So my k value is going to equal -6 over 2. That is going to equal -3. So therefore, automatically, what is going to be the t value? So the t value is going to be here. And that is going to be sine of pi over 2. And if the question asks you to evaluate, find the value of sine over pi over 2. And according to what we have sketched before, the value of sine of pi over 2, so it's going to be right there. This is sine pi over 2. So that is going to be a value of 1. And of course, you can use your calculator for that. So make sure it's in radian unit. So let me check that as well. So sine of pi divided by 2. So yes, that is going to be a value of 1. So by using the periodicity function. Okay, and the last one, C. I make it slightly more complicated. I have sine 9 pi over 4. So sine 9 pi over 4. Okay, if you notice, so previously the 2 question is already, what do you call that? We have like 2 expression being separated. One term at the front, one term at the bottom. And we can actually guess, so which one is going to be the 2 pi k term. But for this one, everything comes in a bulk. I just have 9 pi over 4. So what I suggested for you to do is, when you come across something like this, use your calculator. So find what is going to be 9 divided by 4. So 9 divided by 4, according to calculator, you will get a value of 2 point something. So you will get 2.25. So basically, so this is going to equal 2 pi plus something. So I can actually write something like this. So I'm going to write this as sine of 2 pi, so plus, so let's put 2 pi at the back. So how do I explain this to you? So it's going to be something like this. So 9 pi over 4 is actually, so if I were to omit the pi, so that thing will look simpler to you. So 9 over 4 is actually 2 plus, okay, so this is going to be 2 over 5. If you change this in term using your calculator, you get 2 plus 1 over 4, because 0.25 is actually 1 over 4. And if you put 9 over 4 pi, of course, this is going to equal 2 pi plus 1 over 4 pi. So this is what happened over here. I can actually write this as sine of pi over 4 plus 2 pi. And right away here, we can identify that this is going to be the 2 pi k part, for which our value of k, that is going to equal 1. So basically, so this is actually equivalent to sine of pi over 4. And if I'm not mistaken, sine of pi over 4, so that is going to equal 1 over 2. So let me check that. So sine of pi over 4. No, that's going to equal, it doesn't really reach that value. So this is 1 over square root of 2. So if you use the special angle. Okay. So this is going to be 1 over square root of 2, depending. If the question asks you to leave until here, just leave it until here. But if the question actually asks you to find the exact value, so you have to answer until 1 over square root of 2, or 0.7071 from your calculator. Okay, so for a question like this, so we are going to set something like, so use periodicity. So I have actually a bunch of examples that are written over here. So I says use the periodicity of sine and cosine to find the following values. So you have to apply the periodicity somehow and find what is going to be the value of t, and prove that for each of this you have to find what is going to be the t, so that sine t plus 2 pi k is going to equal sine t, and cos t plus 2 pi k is going to equal cos of t. So please try. This is actually not something that is too complicated, but of course it comes with the practice. So therefore, what I would like you to do is please try to attempt these problems right here. And of course, so if you have any problem with finding the periodicity, so let me know so that we can discuss.